Okay, so a cone has to be a separate category just like the cylinder because the base is a circle, which is not a polygon because there's no sides. So a cone, again, is a 3D figure with a circular base rather than a polygon base, connected by a curved surface to a single vertex. So there's a surface area formula for a cone, and that is, we first have to get the area of the circular base, which is pi r squared, plus, so that's the circular base. Then to get the curved surface, you take pi times the radius times the slant height. So you have to know that that L is slant height again. And this is for your lateral area or the curved surface. So here they give you the lateral, not lateral, sorry, the curved slant height rather, sorry, the slant height, as opposed to a more difficult problem where they wouldn't necessarily have to give that slant height, and then it would be enough information to give you the height of the cylinder and the radius, and then you could use that right triangle that they're showing you, a 5, 12, 13, to get the slant height. So there are application problems where you have to find the slant height using Pythagorean theorem. However, I'm not doing any like that today. So for surface area, and I'm going to keep my answer in terms of pi, which I specify for the examples for you to do. I'm going to plug in the 5 for the radius, plus 5 for the radius again, 13 for the slant height. So I get 25 pi plus 65 pi, both in terms of pi, so I can combine them and get 90 pi as my final answer. And it's inches squared. Okay. The last one is more algebra than geometry because the formula is given to you. So the lateral surface area can be represented by this equation. Now notice this lateral area is different from the formula that I gave you here with the pi r L there. They do pi r, and instead of L, they're using the Pythagorean theorem to define that slant height. So you're like in this formula, but it's given to you here, so that's not really being tested. They give you that the lateral surface area, which is this number here, is 247.85. They ask you to find the height to the nearest hundredth. So they've given you radius. So we could plug radius into the formula, 6.5. And then in here, I'm going to plug in 6.5 for the radius again, squared, plus h squared, which we're trying to solve for. So again, this is more algebra. We need to divide both sides first by that 6.5 pi. 6.5 pi. And you could put this into the calculator just like that, and you get this number 12.1374 ... which I use the exact value. If it's the first thing you're putting in the calculator, they'll assign it the value of A. I'll bring down the square root. Instead of 6.5 squared, I would just simplify that and get 42.25 plus h squared. So the 42.25 took the place of the 6.5 squared. Now to get rid of the square root, we need to square both sides. So now I get rid of the square root on the right-hand side. You're going to do a lot more with radical equations next year in Algebra 2. And on the left-hand side, I put into the calculator the letter A squared so that it squared that exact value. And I got 147.316 dot dot dot. And then after that, I could subtract both sides by the 42.25. Shh, Blake, you could quietly listen. Sorry, guys. And I get 105.066. Again, I keep using the exact values using the letter in the calculator. Equals h squared. And then finally, before I lose it on Blake, square root of both sides. And I would take the square root of that exact number and get 10. Oh, great. My pen's not working right now. It comes out to 10.25 if you round it to the nearest hundredth. Blake, you want to say bye?
My leg is stuck.
All right. That's her bye.